Good morning. Today we will discuss about electric circuits and Ohm's law. In the previous class, we have studied about electric current, electric potential and potential difference. We studied that potential difference needs to be maintained so as to ensure a steady flow of current. Now, this current requires a continuous path. This current will require a closed path. Now, what is this closed path called? This closed path is nothing but an electric circuit. Now, how to define an electric circuit? What is an electric circuit? It is a closed path through which current can flow. Now, let's define an electric circuit. A closed continuous path for flow of current is an electric circuit. A closed continuous path for flow of current is an electric circuit. Now, a question arises that if we want to consider a very simple electric circuit with minimal number of appliances. Now, the simplest electric circuit should have some essential things connected to it or essential components of an electric circuit. What are they? For the simplest electric circuit, we require a source of current, we require a switch, and we require conducting wires. Now, these three are the essential components of any circuit. Apart from these three, we can have any number of appliances connected in that circuit, but these three are compulsory. Now, in case of a source of current, we can have a battery, but apart from this, we can also have a cell. In a very simple circuit, we can have a cell or the supply, the electric supply. A switch is acting like a conducting link. We can control the current, whether we want the current to flow through the circuit or not. As per our requirement, we can switch on the circuit or switch off the circuit. So that's the necessity of having a switch. And lastly, the path will be continuous only when the material used for making that path is a good conductor of electricity. So we require wires made up of conducting materials. So these three are the essential components of any electric circuit. Now, an electric circuit is of two types. It may be open or it may be closed, depending upon whether the circuit is in the on state or the off state, depending upon whether the switch has been put in the on state or off state. An open circuit means from which no current is flowing. So this is possible only when the switch has been put in the off state. A closed circuit is when current is flowing through the circuit. This means when the switch is in the on state. So open circuit means no current is drawn from the circuit, switch is in the off state. And no current is flowing. Closed circuit means the switch is in the on state and current is flowing. Now I would like to show you one picture so that this concept of open and closed circuit becomes clear to you. Check this picture. You can see the switch is being put in on and off state alternately, and accordingly the bulb is glowing when the switch is pressed on, and it is switched off as soon as the switch is put in the off state. So when the bulb glows, the circuit is closed, and when the bulb does not glow, the circuit is open. Understood? If you want to draw an electric circuit, then just imagine drawing all the appliances in the way as they actually look like would be quite a difficult task. And apart from this, it will be quite time consuming. To simplify this task, to make the diagrammatic representation of an electric circuit simple, people make use of certain symbols. Now we will study a couple of these symbols, and using the symbols we will try to draw a simple circuit. So let's begin. We will begin with the symbol for a cell. So the symbol for cell is, as we all know, that a cell has a positive terminal and a negative terminal. So the positive terminal is shown by a long line, while the negative terminal is represented by a shorter line. Next, a series combination of cells, that is a battery. I will show you the symbol for a battery of two cells. You can see I have shown you the combination of three cells actually. So there are three positive terminals and three negative terminals. Next, wires, a straight line. Next, a wire joint. Two wires crossing each other without touching. A fixed resistance. Rheostat. An electric bulb. You can draw this, or you can draw this. A closed key or switch. An open key or switch. A meter. voltmeter, galvanometer. So these are some common circuit symbols. We will use a couple of these to draw a very simple circuit. Let's begin with the source of current, then a closed key. We need an ammeter to measure the current. We will mark the terminals. Then a resistor will complete the circuit, and we will connect a voltmeter in parallel with the resistor and again mark the terminals. Now, before completing the circuit diagram, we have to ensure that we have indicated the direction of flow of current. So the current is flowing from the positive terminal to the negative terminal. So this is a very simple circuit diagram. George Simon Ohm. Now, George Simon Ohm was a German physicist and mathematician. As a school teacher, Ohm began his research with the new electrochemical cell invented by Italian scientist Alessandro Volta. Using equipment of his own creation, Ohm found that there is a direct proportionality between the potential difference applied across a conductor and the resultant electric current. This relationship is known as Ohm's law. Now, we will study in a bit detail as how that experiment was conducted and ultimately what conclusion was drawn from that experiment. A setup similar to what is shown in the picture was used by Sir George Simon Ohm to study the dependence of potential difference and current. Now he found that as he went on increasing the value of potential difference across the ends of the conductor, the amount of current flowing through the circuit went on increasing. So he established a direct dependence, direct proportionality between potential difference and current. He observed that these two physical quantities are directly dependent on each other. But in the same time, one thing was kept into consideration, that this proportionality was valid until all physical conditions were considered to be constant. This means that with passage of time, when temperature of the conductor increases, then this proportionality is no longer valid. This means if temperature remains constant, pressure remains constant, the wire, the dimensions of the wire, the physical conditions of the wire remains constant. Only up till then this proportionality is valid. An equivalent circuit diagram of the setup used by George Simon Ohm to develop this relationship is somewhat like this. He used a source of current, and with the help of a variable resistance he was able to control the potential difference applied across the ends of the conductor, and he observed that as the potential difference was varied, accordingly the current flowing through the circuit was also changing. So using the values obtained from this experiment, he plotted a graph, and he found that there is a linear dependence between potential difference and current. By plotting the values obtained from this experiment, he observed that a straight line is obtained that passes through the origin. Hence, he derived a conclusion that the potential difference applied across the ends of a conductor is directly proportional to the current flowing through it, provided all physical conditions remain constant. This is the famous Ohm's law. The statement of Ohm's law is somewhat like this. The current flowing through a conductor is directly proportional to the potential difference applied across its ends until all physical conditions remain constant. Now, with physical conditions, we mean temperature, pressure, and dimensions of the wire. Until all these physical conditions remain constant, the current flowing through a conductor is directly proportional to the applied potential difference. Now, mathematically, V is proportional to I. Now, as we all know that when we want to replace the proportionality sign with an equal to sign, we have to introduce a constant. So that constant is R multiplied by I, which ultimately gives us the expression V is equal to IR. Now R is the constant of proportionality and it is called resistance of the conductor. Resistance offered by the conductor. Now we'll be discussing about resistance a bit later, but prior to that, let's quickly recapitulate the graphical representation of Ohm's law. We have seen that when a graph was plotted between applied potential difference and current, it turned out to be a straight line. Now I would like to ask you one question. If suppose current is plotted on the y-axis and potential difference on the x-axis, then what should be the graph looking like? The graph is again a straight line passing through the origin. Now, if you want to calculate the value of resistance using these graphs, then in the first graph, we have to drop a perpendicular and resistance will be equal to the slope of the graph. Slope is perpendicular by base. So this will be the resistance. In the second graph, again, we will drop a perpendicular in this case resistance will be OB by AB. Understood? Because we have changed the parameters in both the graphs. In the first graph, potential difference is on the y-axis and current is on the x-axis. So slope of the graph will be AB by OB. In the second case, since we have plotted current in the y-axis and potential difference on the x-axis, so now the value of resistance will be given by OB by AB. You can consider that simply the slope of the graph is representing reciprocal of resistance. So in order to find out resistance, we have just considered the reciprocal value of the first one. Understood? So in this manner, you can calculate resistance from the graph. Now the question arises, what is resistance? Resistance is defined as the hindrance to the flow of current. Now what does this word hindrance means? It means an obstruction. Whenever current is flowing through a conductor, it faces some opposition. That opposition is given the name of resistance. Now very easily from Ohm's law, we can obtain an expression for resistance and that turns out to be R equal to V upon I. Okay. Now let's try and understand from where this resistance comes into existence. Just look into this picture. You can see that when the electrons are moving from one end to the other end of the conductor, they are continuously suffering collisions. They are colliding with each other and with the other atoms inside the conductor. Now, the arrangement of particles inside the conductor is called lattice. So the electron has to suffer some obstruction during its motion from one end to the other end of the conductor in the form of collisions. And due to this collision, the momentum of the electrons is substantially reduced. Now, if the motion of the electrons is affected, then this will affect ultimately its velocity. And that is going to bring about a change in the current flowing through the circuit. So that's the reason why resistance comes into existence. This opposition, this hindrance to the movement of electrons inside the conductor is given the name of resistance. Resistance increases if the number of collisions increases, and resistance puts a check on the amount of current flowing through the circuit. Okay, so we will try and obtain an expression for resistance and understand what should be its unit. So from Ohm's law we get V equal to IR, which implies that R is equal to V upon I. Now unit for voltage is volt, unit for current is ampere. So volt per ampere is called ohm, and it is represented by the Greek symbol omega. How to define 1 ohm? One ohm will be equal to 1 volt by 1 ampere. How to define it? If 1 ampere current flows through a conductor when a potential difference of 1 volt is applied, then resistance is said to be 1 ohm. We will discuss about the factors affecting resistance, specific resistance, and ultimately how resistance proves to be an advantage as well as a disadvantage in certain situations. What does it ultimately lead to? All these things we will discuss in our next class. So we'll end our class today at this point. Thank you.